Good afternoon, everyone. I'm Nicole Henderson, Editor-in-Chief at the WHIR, and I'd like to welcome you to today's webinar. Today's session is called Better Storage, Better Business, and will be presented by Boyan Krasnov, Co-founder and Chief of Product at StorePool, and Boyan Ivanov, CEO of StorePool. I will hand it over to Boyan and Boyan in a minute to introduce themselves and StorePool. But before I do, I want to take care of a couple of things. First off, questions. We'll have a few minutes at the end of the session for your questions, but you can submit them at any time using the question function in the webinar software. If you ask a question and it doesn't get answered, somebody will reach out to you by email after the webinar. Or if you have a question you'd rather ask outside a public forum like this, there will be some information on screen during the Q&A period, so you can reach out that way as well. Finally, there will be a video archive of the webinar available if you want to rewatch the presentation or share it with someone else. It'll be available in the archives at thewhir.com/webinars by the end of the week, so make sure to check that out as well. Okay, so let's get started. Welcome, Boyan. Great to have you here today.
Hi, Nicole. Thanks, Nicole. My name is Boyan Krasnov. I'm Chief of Product at StorePool. And also on the call is Boyan Ivanov, my co-founder and our CEO. Today's session is called Better Storage, Better Business. We'll move on to that in a second. So Boyan, are you there?
Hi, from my side as well. I'm glad to be here. Hopefully we'll share some things that are really interesting for our audience. I'll kick off with a few words about StorePool. We started StorePool in 2011 when there was no such term as software-defined anything, no storage, no data center, though we were doing more or less this thing. And it came from the market. We spoke to a number of customers and companies that were struggling with their current storage solutions. And we said there should be a better way to do data storage in the 21st century. It should be simpler, more scalable, more reliable, and obviously it should cost less. And this is how we started StorePool, and we've been doing it for 2.5 years now, and we have really interesting journey along the way. But we'll get into that. So I'll get it back to Krasnov to jump straight into the presentation.
All right. So first, a few words about me. In my school years, I did informatics and went to these international competitions in informatics. Then for my first career, for a pretty long time, I was doing networks and ISPs and router switches, things like that. I've lived in 5 countries, including Bulgaria, where I'm based now. And I'm pretty much doing IT infrastructure in one form or another since 1999. In StorePool, and we started StorePool in 2011, and I've been involved in distributed storage since then. Okay. So our agenda for today is I'll talk a bit about the storage. What is the problem with storage? If everything was hunky-dory with storage, why do we need anything to solve that? And I'll explain why doing storage is hard. We'll look at today's solutions, and then we'll look at tomorrow's solutions. And I'll also show you some performance test results of our solution, and we'll open it to questions and answers at the end. So what's the problem with storage? Well, first of all, I think storage is important. If you look at any cloud architecture or virtualization architecture, there's basically 3 components to it. There is compute, storage, and there is also networking. For us, we think storage is the hardest part of that. Basically, in networking, if you lose a packet, everything is okay. No need to panic. There is, good things we have like TCP that just retransmit the packet and everything's okay. In compute, if you lose a compute node or a CPU, you just move the user to another server and the user is happy. But in storage, if you lose the data, that means a costly and slow recovery from backup, and that's if you have backup, right? So there is a lot bigger impact to storage not working right than to say networking not working right. So what we see in the field is that storage breaks badly and loses data, like existing systems break badly and lose data. They may be too slow and may not be able to handle the performance that you need. And it's also, in a lot of cases, too expensive. Okay. And in reality, in a lot of cases, we see that all of these problems happen. So it's both too expensive and it's too slow and it breaks badly and loses data. And that's not an acceptable situation to have. So what are today's solutions? Today's solutions are, first of all, there is local storage for a lot of cloud and hosting companies rely on this way of storing customer data. And generally, these are companies that don't invest much in the infrastructure, and they just get by, and it lacks. There are a lot of problems with it. So it's performance might be good, but if you lose the node, you lose the data. In a lot of cases, local storage lacks key storage features like thin provisioning and snapshots. It's not an ideal solution, but a lot of people have learned to live with it, and yeah. A lot of people use centralized storage solutions. Most cases these are SANs, and there's a picture of them here. So the main issue with this approach is you typically have one storage node and a lot of compute nodes around it. So there is kind of a many-to-one situation, and in that case, the storage becomes a bottleneck. So it's hard to scale, it's inflexible, it might be a single point of failure depending on the architecture. And there are a lot of examples for this, like most traditional storage vendors, these are all of your traditional storage solutions in that category. A lot of software storage is also in this, has this kind of architecture, centralized architecture, meaning there is one storage box, a lot of compute nodes. Then there is also the what we call marketing-defined storage solutions. So what we've seen recently is that absolutely every vendor out there has said that they also do software-defined storage. But what we see in a lot of cases is these are just exactly the same solutions. Especially the traditional vendors, they would call it software-defined, but they would also want you to buy their box. So it would usually be like the highest end storage controller that you can buy from them, and then you put some software-defined magic on top of it. So you can see things from EMC, NetApp, HP, all the big vendors have some kind of solution like that. And lastly, there are other distributed storage software solutions, which we call first-generation distributed storage software solutions. And they scale, but they're very inefficient. They consume a lot of CPU, a lot of memory. And a big problem with these is that they don't deliver on promised performance. In a lot of cases, they also don't deliver on promised reliability. And I have a couple of examples here, like Ceph and GlusterFS. Even though GlusterFS doesn't really fit well the use case that I'm presenting, the use case that we are talking about. So how can we improve on this situation? How can we make this better? And I don't mean just a gradual improvement on this. I mean like really make it way, way better than the current situation with storage. And that's exactly what we set out to do with Storpool back when we founded it in 2011. It was founded by a team mostly coming from high-performance networking, and we set out to combine storage and compute and networking in the same in one piece of software that provides a distributed storage service. Our initial focus, right now is primary storage, Linux and service providers, which means that we don't make our system great for use cases where this is some second tier, third tier storage. What we try to do is make our system great for service providers who use Linux, right? And the use case, the typical use case, the way people use Storpool typically is for hosting virtual machines. So there would be a cloud service provider, and they would put a live virtual machine images directly in Storpool. So each virtual machine would get its own Storpool volume. And we think Storpool great for that. That's the thing that we've designed it for. With our approach to this is that we've redesigned the storage stack completely from scratch, so that our storage stack, our architecture matches the distributed storage architecture. We've seen with a lot of other vendors that they make a kind of a hack together solution where they would use a standard file system underneath, and we don't think that works well, and we can show that doesn't work well. And the end result is unmatched performance, reliability, and flexibility. So that's us. And we think of this as storage in the 21st century. So we've gotten rid of all the legacy storage stuff out there, and we thought about how do we make this work really well in the 21st century, where there are networks with low latency and huge throughput. There are commodity x86 servers with enormous compute power and high bandwidth. So this is, and what people say about us when they, a CTO of unnamed kind of a major infrastructure software vendor, what he said about some things that we were showing him, he said that this is impossible. Like he didn't believe that we were showing him a real system and not some mock-up. And what we say about this, we didn't know it's impossible, so we just built it, and we're happy that we didn't meet this guy a lot earlier. So this is how a typical storage system, distributed storage system looks like. So there would be a storage cluster underneath. There are storage nodes in there. Each storage node has like a few drives and maybe a few SSDs. There's a storage network in between, and on top you have hypervisors that run virtual machines, and these virtual machines, up there shown on this picture. So what would one want from a storage system? If you've never seen a storage system before, what would you want from one? So we think you would want horizontal scalability, so you don't need to, forklift upgrade your system when you get to a certain number of nodes. And that should be scalability in performance and capacity, not just capacity scales, but performance doesn't, like we see with a lot of systems. It should be based on standard servers and drives and a standard network. And the use of commodity servers and drives brings you huge savings, a huge cost advantage to someone who doesn't use standard servers, like off-the-shelf components. It should have online expansion. It should allow you to make all kinds of online changes. So if you say you have some data on hard drives and in some moment you decide that you've changed your mind and you want that data on SSDs to get better performance, that should be an in-service online operation. You shouldn't have to bring this, the service down to make that work. And same goes for software updates. You shouldn't have to bring the system down to upgrade it. The system storage service should heal itself. You shouldn't have to send a person to physically replace components to make it heal. If anything happens to it, it just should heal itself, right? It should have a simple architecture, and we've actually learned this from customers. They simply really don't like where the architecture of something so fundamental to their business is complex, is complicated. So if there are 3 types of servers and you need to do active-passive pairs for each of these types, it's just really bad. They really don't like it. And it should also not require an additional layer of shared storage underneath. There are a lot of systems that do it that way. Ideally, it should just be servers on a flat Ethernet network. Nothing special about the network, nothing special about the servers. And it should also have brutal efficiency and performance. By that I mean you should be able to get the most of your investment. Like if you bought a drive and that drive can do a certain performance, then you should get that without any further restrictions or bottlenecks. All right. So here is another thing we have. So you have compute, networking, and storage. And nowadays, the compute servers, these are standard x86 servers. You can buy them from a number of vendors. You know the ones. And then on the other side, you have this software-defined distributed storage system, which is also standard x86 servers, which you can buy from this number of vendors. And we have our friend Spock here in the middle, who's not very impressed, because these are basically the same, the same type of server. So what we think would be great for storage, and like hyperscale companies like Google have figured this out as well, is that you could, with the right storage software, you could do storage and compute in the same servers. If the storage system is right, if the storage system only takes, say, 10% of the CPU of each node, then you can use the same servers for storage and compute. So these are your storage and compute converged servers, and you also have a small network. And then the result of this is basically half the servers, because you don't have storage and compute servers. You have just one type of server. Half the network ports, significantly lower footprint in terms of space and utilities. And it's one type of server, so it's a lot easier to manage. So it's a big win overall for operations, for capital requirements, for everything. And the economics of this look like this. First of all, you should use commodity hardware for your storage. For a lot of reasons. It's lower cost, less support. It's a common skill set supporting commodity hardware rather than some weird specialized boxes. You should run storage and virtual machines on the same servers because it basically decreases your footprint nearly by half. And also, other gains that you get in economics are, because it's a large pool of capacity. it's not a lot of separate pools. You don't get, you don't waste 50% of your capacity in each of the servers. You only waste about 10, maybe 20% of capacity overall in the whole pool. That's because you pool capacity, right? So, but also because you pool performance, you allow each user to peak, to receive a lot higher performance than they would otherwise. And overall, and you can see this, if you're a service provider, if you're a hosting company, you've probably already figured this out for your internet connection. Users peak at different times, so there will be one user that has a high performance requirement right now, and then another user would have that requirement in a different time. And it's also the same with storage performance. And you get a lot higher compute density. So with the right distributed storage system, you can think of a situation where IOPS is no longer the bottleneck. So in the typical hosting situation, you can't put more customers on a server because you don't have a fast enough storage system. So if IOPS is no longer the bottleneck, you get a lot more virtual machines per server, and you can also do tricks with the types of CPUs that you select and make the server a lot more cost efficient. So overall, we think better storage means happier customers. They get higher performance basically for the same cost for you. And it also means more customers for you as a hosting provider or as a cloud operator. All right, so we would also like to share some performance numbers. So we have this performance setup, which is 6 servers in our lab on a 10 gigabit Ethernet network. The servers have 12 SSDs and 30 hard drives in them. And we built two storage pools on these servers. One we call a hybrid pool, which keeps 1 copy on SSDs and 2 copies on hard drives spread across the whole, all of the drives basically. And we have an all SSD pool, which keeps 3 copies on SSDs. And so here's some of the performance test results. So with a queue depth of 16, the 4K reads, we can get about 160,000 drives per second from this really small cluster. So 6 servers for us are a small cluster. And even with such small clusters, you can get 160,000 times random read and 60,000 times random write. And you get slightly lower random write performance on the SSDs because there are only 12 SSDs, while in the hybrid case there are a total of 42 drives underneath. So they can handle the write throughput a lot better. And on the sequential test results here are also kind of good. So sequential reading with 1 megabyte blocks, you get about 2,700 megabytes per second from both the hybrid and the OSSD pools. And for sequential writing, you get about 1,400 megabytes per second from the hybrid pool. And again, I need to stress this, it depends, the performance you get out of a system like ours depends a lot on, the types of drives, the number of drives that you have underneath. But even, my point here is that even with a small cluster like this, like only 6 servers and 42 drives in it, you get really, really good performance out of it. So we think distributed storage is the future. We think that there has been a lot of work in this area, like with these first generation solutions that didn't have this kind of performance and this kind of efficiency that we have. We think that in 5 years, everyone will be using distributed storage architectures rather than centralized storage architectures. And we work towards making this happen today rather than waiting 5 years for this to happen. And the reason for this is it's a lot better economically, as you've seen. It's a lot better technically as well. It gives you a lot better reliability than any centralized system could. And we invite you to schedule a demo with us. I would like to show this to you in our lab, which unfortunately we weren't able to do in this format. And we will open to questions and answers now. Nicole?
Thank you so much. So just a reminder that the On24 software that we're using for this webinar, you can actually ask questions right in the software. So I'll give everyone some time to submit those questions. But we've got some questions right now that have come in. The first question we've got here is, how does StorePool handle hardware failures?
All right, so StorePool is a distributed system. So StorePool servers form a cluster, and they monitor the health of each node in the cluster. If a node goes down for whatever reason, which could be hardware, could be its operating system's not behaving well, it's run out of memory, or a lot of different reasons. We just isolate that node and the system continues working with the remaining nodes. And this has been, we've tested this in environments where there are basically constant ongoing problems with hardware and rebooting machines because of bugs in some other software. And we handle really well. We'd really like to show this to you.
Okay, great, thanks. We've got another question here. How is StorePool different from existing software storage solutions?
All right, so first of all, I'd like to make a distinction here. So there are a lot of solutions on the market which are software-defined storage, but they're centralized. So our main difference from these guys that provide centralized storage solutions, even in software, is that StorePool is a distributed storage system. So we have a cluster of machines. If anything happens to any of the storage nodes, the system continues working. Right? There is no single point of failure in it. There is no active-passive failover. And then secondly, there are other distributed storage solutions on the market. We haven't seen or heard of anything that comes close in performance and efficiency to what StorePool can do. And we are also very, very flexible in terms of operational flexibility. So things like changing your mind about how many copies of data you want to keep, and that's online. Upgrading the software, and that's an online operation. Adding more nodes to the cluster, that's an online operation. So things like that, which make the operationally a lot of sense for someone who's using the system.
Okay, great, thanks. So the next question I've got here is, can StorePool aggregate existing storage arrays? Right,
so our primary goal at the moment, and what the system we've designed and the system we've implemented, is usually deployed with local drives in the servers. So that's our focus. That's where you'll get the most benefit. So there would be storage nodes with drives in them. You could, in theory, use external drives, so drives that are not inside the servers, and make a distributed storage cluster out of these. But you lose a lot of the benefits of the distributed storage solution. So we would support that. We don't think it makes a lot of sense in a distributed storage environment to do it.
Okay, thanks. The next question we've got here is in regards to StorePool's pricing. So the question is, what is the pricing model?
All right, I'll leave that to Boyan Ivanov. Are you there?
Okay, I'll pick that one up. Basically, we have we're flexible in our model. We can offer perpetual license, but we also offer pay-as-you-grow subscription, which we see a lot of demand from service providers in particular. The license is based on the needs of the customer, so the required performance and capacity. And this is because it depends on the way the system is architectured.
Okay, thanks. I've got another question here asking, how can I test it?
All right, so there are several ways of, several levels of engagement that you can get with StorePool. First of all, you can talk to us, obviously. The next step then is we can show you StorePool in our lab. So that means no commitment from your side for hardware, etc. And then the next step of engagement is joining our beta, which means we would install StorePool on your servers. So that means you take 3 servers for this purpose with the right network, with the right drives in them. Then we install StorePool on them, and then you can use them for whatever purpose you intend to use them for. Yep.
Okay, thanks. So that's all the questions that we've had come in. Again, if you want to ask any questions after this webinar, all the information is available on the slide right now. So you can get in touch over email or Twitter as well. Also, if you want to schedule a demo, you can contact trial@storepool.com. So to schedule a demo, contact trial@storepool.com. So that's about the presentation today. Again, don't forget that the archive of the slides and the presentation will be available at thewhir.com/webinars. That way you can share it with any colleagues who may have missed it today, or if you want to go back to revisit a slide, maybe some of those performance metrics, you'll be able to do that with the archive video. So I'd like to thank everyone for attending and for submitting your questions. And of course, I'd like to thank StorePool for the presentation today. I think we all learned a lot about the future of storage and what we can do now to improve our storage in order to have a more successful business. So I'd like to thank everyone again and wish everyone a great day. Thanks so much.
Thanks. Thanks for having us. And if you have any other questions, you can also meet us in HostingCon in a week. So we'll be there. That's why we have our photos actually to see it. So we'll be happy to meet you.
Okay, fantastic. Actually, the WHIR will be at HostingCon as well. So looking forward to seeing everyone there next week. Thanks again, everyone, and have a great day.
All right.